Hi guys, and today we're going to be talking about ionic bonding. So under Unit 1, Area Study 1C, dot point 1, this is the learning outcome for today. We're talking about the common properties of ionic compounds. These are the properties here. And we're going to talk about their formation and the nature of ionic bonding, so how it forms, what does an ionic bond look like, and the limitations of this model. So ionic substances, or ionic compounds, are formed through the chemical combination or chemical arrangement of metals and non-metallic elements. Many gemstones are ionic substances. Ionic compounds generally have high melting and boiling points, generally brittle and hard, so they break easily when they're put pressure on, but they're very hard to break. They do not conduct electricity in the solid state, and they're good conductors of electricity when dissolved. Unlike metals, they don't conduct electricity in a solid state, but they do conduct electricity when dissolved or when in a liquid state. And they can be dissolved in water, or they also cannot be dissolved in water. It depends on the particular ionic compound. So based on these properties here, this gives us an understanding of what ionic compounds, their bonding structure would be. With their high melting point, it suggests that they would have strong forces of attraction between the particles, meaning you need lots of energy to break it, meaning it would have a higher melting point. They're hard, with brittle crystals forming, meaning the attraction between the particles is strong. So when you break them, it's quite hard to do because the force of attraction between the particles is strong. They do not conduct electricity in the solid state. So if they do not conduct electricity, it means they do not have free moving ions in the solid state, meaning they're not moving electrons through or other particles. If they do conduct electricity in the molten state, it means that they must have free moving charged particles in the liquid or molten state. Ionic bonding occurs between a metal and non-metal element or atom. During the process, what happens is a metal atom will lose an electron to its non-metal counterpart, and the metal atom will become positively charged, meaning it's a cation. So the key part is that it loses an electron, or more, one or more. A non-metal atom will gain an electron, or more, from a metal atom to become a negatively charged ion, or an anion. So the key part is that one's losing and one's gaining an electron. Here we have an example of what's happening with sodium and chloride, a very common one. So sodium electron configuration is 281, as we know. And if you look at chlorine, it's 287. We have 2 in the first shell, 8 in the second, and 7 in the third. So what's going to happen is we have one valence electron. Now, given that we have less than one, to get less than 4 electrons in the outer shell, it's going to want to lose that electron. So the electron from sodium will move. The electron is lost from sodium metal and gained by chlorine, the non-metal. Now sodium will have a full outer shell of 8 electrons because that one electron has been lost here. And now chlorine will become a full outer shell. So we'll have one electron extra than it did initially, which makes it a negative charge. So as you can see here the electrons being lost, and here the electrons being gained, and then they form a bond together. So these are individual ions, but they form a bond together, and they make this structure here. Sodium in purple, chlorine in green. Sodium chloride, which equals table salt. As I already spoke about, metals lose their electrons to non-metals, and during this process, both receive a full outer shell of electrons, creating charged particles. So similar to how metals bonded together with electrostatic forces, ionic compounds also bond together with electrostatic forces, where non-metals and metals will have a positive charge. So metals have a positive charge and non-metals have negative, and these forces will attract each other together. And this is what will hold them together. As you can see here, here's the sodium ion in the purple. I'm drawing pluses on them to denote the positive charge, and the chlorine has negative. When they bond together, they make an overall neutral charge. You can see here, They're evenly surrounded and spaced apart with each other. So the limitations of this model are that ionic bonding explains many properties, but some cannot be explained. The model cannot explain why different ionic compounds dissolve differently in water. So why table salt dissolves completely in water, but things like silver chloride and sodium nitrate don't dissolve well in water. Why compounds have different shapes as well is also a limitation. So why do some ionic compounds form crystals and some form square structures, or they form different crystal formations? So this is the summary of today's lesson. Ionic bonding occurs between metals and nonmetals. Metals donate electrons to become cations. Nonmetals accept electrons to become anions, and they are held together by strong electrostatic force of attraction. They don't conduct electricity in the solid state, but they do in the molten or liquid state, and their properties are attributed to their chemical structure, which are also limitations of the model. Thanks. This is the questions for today. Questions 1 to 4, chapter review 4.1, page 87 of Chemistry 1 textbook. All right, thanks for watching.